So we have looked at diffusion coefficient in liquid, how to calculate them using the Chapman and Scott, and also the relationship between diffusion coefficient at standard temperature and pressure. Now we're going to be moving on to the diffusion coefficient in a liquid system. Okay, and then for if we have Chapman and Scott for diffusion in gas system, a widely used correlation for liquid diffusivity or diffusion coefficient of small molecule is called Wilke-Chang equation. So this one again is our diffusion coefficient, and the unit again is going to be centimeter squared per second. So in order for us to find the diffusion coefficient, we need to know a few of the values here. So first is the temperature must always be in Kelvin. MB is the molecular weight of the solvent, of the liquid. Okay, and then this value is our association parameter of the solvent, okay, of the liquid. Mu is the viscosity of the solution, okay, viscosity of the solution, and VA is the molar volume of solute as liquid. Okay, so if you know all these variables value, you can substitute into this equation and you can find the diffusion coefficient for the liquid. Okay, and then remember, this is also important, this equation is only valid at low solute concentration and does not apply when the solution has been thickened by addition of high molecular weight polymers. So meaning that is only applicable, this is only applicable when you have a very low concentration of component A, meaning that your solute. So this component A can be in terms of gas or liquid. Component B definitely is your liquid phase. Okay, so if you have a very high concentration of component A of all your solute, this equation is no longer valid. Or you have you're using very high density or high molecular weight polymer, this equation is not valid. This equation is only valid for low solute concentration and not high molecular weight polymer. And these are some of the value of our association value, association coefficient, right? Association parameter. So if you have water, the value is fixed at 2.6. If you have methanol, the value is fixed at 1.9. If you have ethanol, it is fixed for 1.5. And if you have solvent like benzene, heptane, and other unassociated solvent, you can just use the value of 0. So this value is a constant value. So how do you decide which value you want to use? So it depends on your system. What component B do you have? If your component B here is water, then just use the value of 2.6 here. This value for water is going to be 2.6. For methanol is going to be 1.9. And for ethanol is going to be 1.5. And benzene and other unassociated solvent is going to be equal to 1. So this is actually an example on how to actually calculate diffusion coefficient of benzene in toluene and toluene in benzene at 110 degrees Celsius. Okay, so you have, first of all, you have benzene in toluene, right? So this is your component B. And then you have toluene in benzene. So this is going to be your component B. So AB, so an AB. So you can just change it, change the orientation. So you have all the values here. Is already given to you. You know the value of M, you know the value of VA, you know the value of viscosity at 110 degrees Celsius. So this is can actually be VB or VA, doesn't matter. Is it VA or B? Oh, sorry, VA. Okay, so VA. You now have the value of VA here. So this one we already know. If it's benzene, toluene, or other, the value is going to be 1. So if you have here, you want to find the diffusivity of benzene in toluene. So your MB here is going to be for, so if you have benzene into toluene, okay, so benzene into toluene, your MB is going to be for toluene. So this for the first system. If you have toluene into benzene, your MB, molecular weight B of component B, is going to be for benzene. Okay, and then temperature and viscosity. So you already know the temperature and viscosity. So you can calculate this value and find the value of diffusion coefficient. So please go back and try to solve this question, whether you can get the value of diffusion coefficient of benzene toluene and toluene and benzene at 110 degrees Celsius.